So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says 1 surrounded by zeros. The problem is pretty simple and it asks you to think rather than apply algorithms. Given an n cross n binary matrix grid, find the total count of all cells containing 1 that are unable to move out of the grid through a path of adjacent ones. So adjacent means you can only move in 4 directions: up, down, left, right. Diagonal means they are not allowed. And assume that the space immediately outside the grid is open path. Any one located directly on the outer boundary of grid row can immediately step out, and any one connected to it can follow and also step out of the grid. So this one can step out, so we will not count this. Rest there are 3 ones and hence 3 is the answer. You see, this one is stepped out and this is connected to this all, so these 4 ones are not counted like this. What are counted is this. Obviously this can step out, this can step out, and these 3 can step out. So we have counted 3 plus 3, which is 6, and 6 is the output. So cool, we are provided with this. How can we do it with this one? So the question itself mentions us. Often a time you will not get straightforward questions like this, but says that hey, we are just wanted surrounded by zeros. So what surrounded by 0 means? It means that do not include, I will repeat, do not include any terminal ones. What do I mean? Terminal means like any of this is standing on the edge. Now we don't want that, so how can we deal with this one? So let's get it simple. We don't want that, don't count that, remove it. We don't want it, don't count, remove it just, and consider the rest. And here is the gist of the problem, and within these 2 lines you will get to understand how this problem is being solved. Obviously we wanted to traverse the matrix. How are we going to do this? This can be done by DFS or BFS, both. You can get DFS solution already. I have also coded it earlier. You can check my videos, or it can be shown up over here, but now this time we'll do it by BFS, which is a better way, a faster way to deal with this such kind of problems. Now for BFS we need what? We need a queue, which would be a 1D array containing your x and y position coordinate, I can say. I'll name it as queue new linked list. Cool. Now we have a queue. Excellent. What next? Up next we wanted to fulfill this queue, right? And to fulfill this queue, what I will be doing here is I'll check one by one. As 0 I is less than a dot len I plus plus, and if I found out that a of I and 0 is equal to 1, it is the terminal point, so I'll just queue off of this coordinate within q. New int of I comma 0. Why I comma 0? Because we found I and 0. Similarly I can go a of I and a of I dot length minus 1 is equal to 1. Then again it is periphery, so q dot offer new int of I, a of I dot length minus 1. Cool. We have did it for I. Let's do it for j as well. that means the columns as well. For int j is equal to 0, j is less than a of I dot length in this case because we are dealing with columns, j plus plus. If I'm taking a first row, a of 0, 0th row with jth column, if I see it 1, you know the drill, offer this within 0 comma j. Again you have a peripheral case of a of a dot length minus 1 with j, and if that is the case, okay, this is equal to 1, and if that is the case, q dot offer new int of a dot length minus 1 along with j. At this moment, can I say that, hey, I have marked all the terminal elements? Yes, I can say that. What else I need to do is BFS, just remove this one. Iteratively remove this with the help of BFS. What from the grid A with a Q. That's it. Once I have removed this with BFS, I will go ahead within a simple technique where I can use CNT as count. This would be my return type, and so returning CNT here itself. And since I'm returning the count, I need to check it from 1. Why I'm not using 0? Because I have already nullified zeros, so I'm not checking zeros again. Okay, so a of I dot a dot length minus 1, again minus 1 because I have already eliminated the last row, so not checking that. Same goes with column, I have eliminated the first, so goes with 1 j a of I dot length minus 1 j plus plus because remove the last. Now in this case, if I found that a of I j is equal to 1, in that case only what I would do is q dot offer new int of ij, and I will also call a BFS which would remove it a and q, and again it will give me BFS function would not only remove it, it will also count it. Remove means I am removing 3 ones, that means I am counting 3 ones, and I would be returning 3 ones, so whatever I will be returning, just include it within the count. Cool, I think we have achieved a lot now. Let's implement BFS and we are done with this. So it would return int as we have seen earlier as well. It is requiring a matrix q of again int array, because again we have a point system x and y. So cool, so far so good. I wanted a count here. This was the count specific to BFS, so CNT is what I am going to return. And while you know the drill for BFS, how we are doing it is not q is empty, so until it is not empty, I am going to take out one by one element. That means I am going to pull the elements. So the moment I am pulling it, I am checking x and y. X is equal to current of 0, y is equal to current of 1. So I have x, y both. Now what? Consider what I wanted to have is, I wanted to check if a of x and y, if it is equal to 0, then I don't need them because it's already 0. I don't need to count zeros, right? But I need to count 1. So I'll count 1 CNT plus plus, and I will set it up. So count and set as visited. How do I set as visited? A of x, y marking as 0. Cool. I guess this is self-explanatory now, but I have to add the adjacent. how do I do? Fortunately, we have only 4 sides, so I'll just take directions. There are only 4 directions, and you know it. What are they? 0, 1, 0, minus 1. So these are 0, 1 means right, 1, 0 down, 0, minus 1 left, and minus 1, 0 means up. So we have all the directions with us without any wasting any time. I is equal to 0, I is less than del dot length, I plus plus, and we need to have a new x, which is x plus direction of I, and new y, which is y plus direction of I plus 1. But remember, I plus 1 can be negative, so we don't want that, and hence modulo this dot length. I mean, not negative, I plus 1 can exceed the directions length, so we don't want that. So that is why. And if in any chances that nx is less than 0 or nx is greater than or equal to a dot length, or ny is less than 0 or ny is greater than or equal to a of nx dot length, in any of these cases I don't want to feed it, so I'll just continue to the next one. Else what I'm going to do is I'll check that first if a of nx ny, if it is equal to 1, in that case only I am going to offer it to q. New int of nx ny. Oops, I have mistaken the brackets. Yup. So populating the queue and incrementing the count one by one as I set it to 0. And what do I else want? Nothing. Let me compile this one for sample test cases, since there are some semicolon missing. Line number 16. Oh, yeah, double F. And anything else I'm missing? Line number 36 is J plus plus. Okay, it's not just plus plus. What is wrong? Oh, it is somewhere J, it is somewhere I don't want that. 0. Cannot find symbol X. This is strange. It is DIRS. Okay, now I see. Directions it is, right. So cool. Cool. We have passed sample test cases. Let me check for the rest. And as you can see, we have also solved for all the rest of test cases. Now this question is quite interesting and it has been asked in Google. The topic you can see, it's a DFS, BFS, graph and data structure. Obviously you can solve this problem with depth first search as well. The logic overall remains the same, which is over here. Traversal, obviously traversal you need, that is what it comes over here. So in 2 ways we can have it generally. There are also multiple ways. If you know any other way apart from this, do let me know in the comments. I will reply to each of the comments and I'll see you in the next one.